dear students. Today's lesson is about the 3D trigonometry. It means we will handle 3D shapes like cuboids, like cubes, pyramids, cones, and we have to find the length of an edge of a pyramid, for example, or the angle that a line forms with the base, for example. Let's now give a definition about what is the angle between a line and a plane. What is the angle between a line and a plane? It is the angle between the line and its projection on the plane. Let's take some examples. Here is a cuboid, and here is the longest diagonal of the cuboid. And we need to find the angle between this line and the base of the cuboid, which is yellow highlighted. The definition says it is the angle between this line and its projection on the plane. The line has two ends. One of the ends is fixed at the plane, and the other end is free. So, how to find the angle? We will simply, from the free end, you drop a perpendicular to the plane, then join to the fixed end. Usually, the perpendicular is one of the edges of the cuboid. So, where is the line? And where is the projection? And where is the plane? This is the line. And this is its projection on the plane. So, the angle is this angle, which is this black one. It is the angle between the line and its projection on the plane. Let's take another example, the pyramid. We need to find the angle between the red line and this plane, which is the base of the pyramid. Where is the perpendicular? How we drop it? Usually, all the edges of the pyramid are equal. And the top point, we call it the apex. And we drop a perpendicular from the top point to the center of the base. By the way, the base looks like a parallelogram, but it's a rectangle. And also the perpendicular, when we drop a perpendicular to the center of the base, you might think that this perpendicular is inclined. No, it's perpendicular height. We call it the perpendicular height. Let's repeat what we said about the cuboid. We'll say it for the pyramid also. This is the line. It has two ends. One of them fixed in the plane, and the other one is free. From the free end, you drop a perpendicular to the plane, then join. This line you are joining, we call it its projection on the plane. Where is the line? It is the red one of the edges. And this is its projection on the plane. What does it mean, the word projection? It means when the line falls, where will it fall exactly? On this dotted line. So what about the angle? It is this black one. Let's shade it in blue color. This is the angle between the line and its projection on the plane. Now, in the cube, in this case, not always the plane is horizontal. Sometimes the plane is vertical. This is the wall, the side wall. How to find the projection and how to find the angle between this line and this plane? Let's say automatically, what are the steps to find it? Here is the line and here is the plane. The line has a fixed point, fixed end on the plane, and a free end. From the free end, you drop a perpendicular to the plane, then join. As usual, you have to expect that the perpendicular line you are dropping is one of the edge. From the free end, I drop a perpendicular to the plane, then join to the fixed end. This is sure a right angle. So the angle is between the line and its projection on the plane. Ta-da-da! It's this one. Let's shade it in blue. What about the cone? This is the apex of the cone, which is the top point, and we need to drop a perpendicular to the center of the base. From the line, We drop a perpendicular from the free end, drop a perpendicular to the center of the base, which is a circle, the center of the circle, then join. This is the perpendicular height of the cone, and this is the angle we need to find. How to find it? Using trigonometry, the normal, what is the normal method when we find a right angle? When there is a right angle, you are allowed to use SOHCAHTOA. When there is a right angle, you are allowed to use SOHCAHTOA. Usually in this type of questions, you have to search for the right angle because you dropped the perpendicular, so there is a right angle. Now let's go to an example. Here is a past paper question. This is my workbook. Let's read. The diagram shows a pyramid on a square base. Wow, a square, then the four sides are equal. A, B, C, D. The diagonals of the base AC and BD intersect at M. I need the point of intersection. The sides of the square are 8 centimeters, and the vertical height of the pyramid PM is 5 centimeters. Calculate the length of the edge PB. So this is the edge PB. I'll write a question mark here. And the best method to solve 3D trig is to extract 2D shapes from the 3D shape. This is the best successful method ever. First of all, we have to extract the base. What did you say about the base? We said that the base is a square. Okay, here is the square. And here is its diagonal. Of course, the square has a right angle, so we can use Pythagoras theorem. We'll deal with this. We'll deal with this dotted triangle. What are the dimensions? The square is 8 centimeters. All four sides are 8. And what are the names of the corner? Please write the names, the letter A, B, C, D. And we need to find the diagonal, which is DB. Okay? Why is it 3 marks? Because first of all, we'll find the diagonal DB. Then when midpoint M bisects the base into bisects the diagonal into 2 equal parts, then we'll extract, this is my intention, we'll extract this triangle. But when you extract it, it will look like a right angle triangle, not like the one which is 3D. In the 3D shapes, you will not feel it is a right angle triangle unless when you have experience, you will imagine it one time by one time. So first of all, our first step is finding dB. Pythagoras theorem, dB squared is equal to 8 squared plus 8 squared. It means 64 plus 64, it will be 128. But we don't need dB squared, we need dB. It's square root of 128. You will find the square root of answer equals, it will be an infinite decimal, irrational number. It is 11.314, and it's an infinite decimal. But I prefer to write it as thirds because thirds are exact. Repeat, thirds are exact. Repeat, thirds are exact. So square root of 128 is much better than 11.314, which I will cut it, and this will affect our accuracy. Now let's complete. When we found this dB, we don't need dB exactly. We need the midpoint, which is M, because when you take this red dotted triangle, this one, write the letters in order to imagine it. This is P, M, and here is B. The height is 5 centimeters, and MB, we have to find it. MB is DB divided by 2, which is, you have the answer on your calculator now, divided by 2. It will be 5.66 centimeters. I should write all my information on the drawing, but on the diagram. But take care, these values are rounded. They are not exact. Then, what do you want to know? Now we need to find this PB. What to use? Pythagoras theorem. Exactly. So PB squared is equal to 5 squared plus 5.66 5.66 squared. Take care, it's on your display. Here is my full display. I just write answer squared. Okay, so answer squared plus 5 squared equals, wow, it's 57. So if you need to find PB, you click square root of answer. Root answer equals, it is 7.5498 before rounding, but write it on the answer line as rounded. So 7.553 significant figures or more. As soon as we finish this part, he will ask me about the expected question. He needs the angle between the line and the plane. The line, which is PB, the plane, which is the base, ABCD. Here is the question. Calculate the angle between PB and the base ABCD. Here is the line. Here is the yellow plane. The line has two ends, one of them fixed in the plane, and the other one is the free end up at the apex. When from the free end, you drop a perpendicular, then join. Okay, I'll do everything now. From the free end, you drop a perpendicular, then join. This is the perpendicular height. So where is the angle? The angle is between the line and its projection on the plane. Da-da-da. It is this one, the black one. We already extracted the triangle. When we extracted the triangle, we know the opposite of the angle. We know the adjacent of the angle. So we deal with tan. Why is it worth 3 marks? It is just SOHCAHTOA. So, opposite over adjacent. It's tan. So, why is it worth 3 marks? Because one of the marks is naming the angle. You have to name it. You have to write that you need to find angle PBM. Be proud of mentioning the angle is opposite over adjacent. Okay? And then to find the angle PBM, it is tan inverse this value, which is 5 over 5.66, which is, if you lost 5.66, the original value of it, I prefer you store it on the calculator. In this type of questions of paper 4, all the steps are relying on the previous steps. So in order not to lose accuracy, I prefer to find it once more from here. Okay, it is square root of 128 equals, then you divide it by 2, you'll get it 5.656854249. Da-da-da. Then 5 divided by answer equals, then shift tan answer equal, you will get it. It is 41.47, it is 41.5 degrees. Any angle should be rounded to 1 decimal place in CIE. Next question. It's a very simple question, but it has a great idea. He gave me, it's a question from the real life. Jules has a fish tank in the shape of a cuboid measuring 46 by 24 by 20 centimeters. Calculate the length of the diagonal shown in the diagram. As I said before, this is the longest diagonal of the cuboid. How to find its, now he doesn't want anything about angles. It's only a diagonal. How to find this diagonal? We said before, we have to extract the base first. Okay, it is a rectangle. After extracting the base, expect that we need to find its diagonal. We need to find the diagonal of the base. Okay, what do you know about this triangle? Write the dimensions, copy and paste the dimensions of the base. 46 by 24 centimeters. Now we'll deal this dotted triangle, and we need, our target now is to find its diagonal. There are no name, no label, so we name it X. Okay, now because a rectangle, of course, is having right angle, so we can use Pythagoras easily. X squared is equal to 46 squared plus 24 squared. 46 squared plus 24. Calculators, all of you work with me. 46 squared plus 24 squared is equal to 2692. X is square root of 2692. Click square root, answer equals, and you write it in decimals, but we will need it as thirds. Thirds are exact. Repeat, thirds are exact. It is 51.88 centimeters. Next part. Of course, you should divide the area you're answering in neatly, be organized. We need the examiner, when he sees your paper, he finds it neatly done for your benefit. So now we need to extract the triangle. Here is the triangle, and the base, we drew it in blue. Of course, the edge of the cuboid is perpendicular to the base, so it's perpendicular to any line in the base. What are the names? No names. Here is X, and here is X, which I got it before. It is square root of 2692. Do you know anything about the height? Yes, it's given. It's 20 centimeters. Now, what do you want now? I need to find this diagonal. I can name it Y. So, for this yellow highlighted triangle, I extracted it. Everything will be easy when you extract the shapes, the 2D shapes from this 3D shape. Again, another Pythagoras, y squared is equal to square root of 2692, but squared plus 20 squared. Okay, so you have your answer on the display before. You just answer squared. It is 2692. Okay, when you square a square root, so it will be an exact answer. Plus 20 squared, which is 400, the answer will be 3092. Now you need to find y. Y equals square root of 3092. Root answer equal, you will get 55.6057, so rounded to be 55.6 centimeters. Does it make sense? Yes. When you have a look at the dimensions, it should be the longest diagonal, which is longer than X, of course. X was 51 point something, this is 55 point something. We need to find the easiest method and the fastest method. Now, here is the fastest method, the longest diagonal. It is the square root of the sum of squares of the 3 dimensions of the cuboid. Length squared plus width squared plus height squared. Ta-da-da! Magic. It is 46 squared plus 24 squared plus 20 squared. Let's have the challenge. Yalla, let's go. 46 squared plus 24 squared plus 20 squared. And you find square root of this answer. It is the same. Is it magic? No, not magic. We did Pythagoras twice. It is simply doing Pythagoras twice. Da-da-da. Now, the last idea we'll take today is about a wedge. This wedge, we call it triangular prism. What's the meaning of that prism? We'll take prisms in mensuration in a coming video. So the diagram shows a triangular prism of length 12 centimeters. Triangle ABC is a cross-section of the prism. Angle BAC is 90 degrees, AC is 6, AB is 5, and all dimensions are written already on the diagram. Calculate the angle between the line CE and the base ABED. So how to find the angle between the line and the plane? It is the angle between the line and its projection on the plane. From the free end, you drop a perpendicular, then join. This is perpendicular already. He mentioned that the edge is perpendicular to the floor, and we need to find this black angle, Okay, everything is given, but we need to extract the base as usual. Extract the base, please. Its color is blue. In French, it is turquoise. This is 12 centimeters, and this is 5 centimeters. We need to find this dotted line, which is navy blue. Of course, the rectangle has a right angle, 4 angles of right angle. And now we'll find this E, A. This is our target now. And this is 5 centimeters, 12 centimeters, and we need to find EA. This is B, and this is D. A, B, E, D. It looks like a parallelogram in the 3D, but actually it is a rectangle. Now, how to find this diagonal? It is AE squared, Pythagoras theorem, equals 5 squared plus 12 squared. Wow, it is 169. It's a famous triangle we took before in Pythagoras video, you remember? AE is the square root of 169, which is 13 centimeters. We remember. Next step is dealing with this dotted triangle. Okay, let's extract the dotted triangle. When you extract a 2D shape from a 3D shape, you will feel the 90 degrees and you will have more sense to solve. The height of the triangle is 6 centimeters, and this base is, remember, we need the names, we need to label. This is C, and the point below C is A, and the point to the east of it is E, and this is the dotted line, which is AE, AE. It is this dotted line, which is 13 centimeters. What do you need to know? I need to find this angle. Remember, it's 4 marks. Why 4 marks? Because the first part is worth 1 mark, finding the 13 centimeters. And I'm reminding you, naming the angle is very important. The angle, name it by 3 letters, and the fixed edge, of the line will always nominate the angle. The angle is E, but you cannot say just E. E is having many lines passing through E. So you'll write here that this is the opposite to the angle. This is the adjacent. So it is tan. Tan CEA is opposite over adjacent. 6 over 30. Divide your area of answering into with using a ruler like that, and angle CEA is equal to tan inverse 6 over 30. Shift tan 6 over 13 equals, when you need to find an angle, you have to click shift. The answer is 24.775, rounded to 1 decimal place. You will write it on the answer line, 24.8 degrees. Don't forget the bubble. 24.8 degrees. And that's all for today. Thank you, my dear students. See you in the next video. Bearings. Bye-bye.